Lesson 12.2 introduces us to the idea of sequences in series, and in particular, arithmetic sequences in series. A sequence is just, a list of numbers, and when it's arithmetic, then you have consecutive terms that have a common difference, and we call that common difference D. So if we take a look at these two sequences down here, we can see it's a list of numbers, and when they're increasing by a fixed number, that's our common difference. So we can think about, to get from the 1 to the 4, it's increasing by 3. To get from the 4 to the 7, it's increasing by 3 again, plus 3, plus 3. So in this case, sorry that got sloppy there, that common difference is 3. So arithmetic sequence with a common difference of 3. This next example over here, you can see that the numbers are decreasing rather than increasing, so your common difference will end up being negative. To get from the 1 to the negative 1, you're going down by 2, so negative 2. To get from the negative 1 to the negative 3, again, we're decreasing by 2. Decreasing by 2 here, and 2 here. We have a common difference, which is negative 2. So here's another example of an arithmetic sequence. Oftentimes we're asked to tell whether or not a sequence is arithmetic. Sometimes you can tell just by looking, is it increasing or decreasing by the same number? But if you need to show any math on if you're saying yes, how do you actually know? There's a pretty easy way to do that. You can start with the second term, and let's take this 86 and subtract the 97 to see what the difference is. This will help us get that negative value because we can see the numbers are going down, and we get a negative 11 for that common difference. Now let's do the same thing again. This time go one term out and take the 75 minus the 86. And we can see again, we're getting another negative 11. So far, they seem to be decreasing by the same amount. One more time, the next term, we can take this 64 and minus 75, and we get negative 11. So when you kind of do this math to double check, you can see that it's decreasing by the same number. It has a common difference of negative 11. This one is arithmetic. If we take a look at the next sequence, maybe you could say, well, it's not increasing by the same number just at a quick glance. To get from 1 to 4 is adding 3, then you're adding 5, then 7. So it's not arithmetic, but how are you going to show that to anyone? What kind of math can you do? So same idea. If you just take the second term out and subtract the first, 4 minus 1 is 3. So the first difference is 3. Now do the same thing. Go to the next term out, this 9 minus the 4, and we get 5. So already we can tell that we don't have a common difference, which means this will not be arithmetic. Just in case we've done some math wrong, let's go ahead and do the next one, 16 minus 9. And we get 7. Clearly, we are not getting a common difference, so this one is not arithmetic. When you have determined that you have an arithmetic sequence, there are a couple ways to write the rule for that sequence. This one is called an explicit rule. This is what you're going to be using for most of this lesson, but I am going to show you what the recursive rule looks like also, just to give you the introduction to that. Here's our rule. This is A with a subscript of n. So you're going to hear me say A sub n a lot. And I know that sometimes that sounds weird and people think I'm saying something else, but this is A sub n equals A sub 1, subscript of 1. That A sub 1 is going to be the first term of your sequence. Then plus, and you have n minus 1 in parentheses. N is going to represent, the number of term you're trying to find, and D, there's that common difference. So in order to write an explicit rule for an arithmetic sequence, you need to have the first term and the common difference. Basically, that is enough to write the rule, and that's kind of your goal anytime you're asked to write a rule for an arithmetic sequence. A rule is going to be helpful, if you're trying to find the 50th term. That's where this is helpful. Instead of having to write the whole sequence out to get to the 50th number you write down, you will be able to just plug in a 50 for n, into the rule that you came up with, and that's how you'd get the 50th term. But we'll get to that. I just mentioned also that we can write recursive rules. So a recursive rule is where terms are generated using the previous term in the sequence. Here you're going to see a new symbol, this a sub n minus 1. When you see that, that's a symbol that represents the previous term in the sequence. Basically, a recursive rule works by telling you here's what you do to the previous term to get the next term. You always need the previous term, it's right here in the rule, in order to get the next one. So for a recursive rule, there's two pieces to it. You start out with the first term, so you have to identify that. And then you have to say, what do you do to that first term, and that's where your common difference comes in. I just want to go through a quick example. There are videos of kind of the three things you're going to come across with writing arithmetic sequences, but just to give you an introduction, I'll do this one in here. To write an explicit rule, we'll start with that one. That's the a sub n equals a1 plus n minus 1 times d. So to write this, we want to identify the first term and the common difference. The easiest problems are going to be when they give you the first term and the difference somehow. In this case, we can tell what the first term is. It's a 5. And then can we figure out what the common difference is? What are we increasing by? To get from 5 to 11, 11 to 17, we can see that that common difference is a 6. So when we come down here and write the rule, we plug in those two numbers. We're going to plug in a 5 for a1 plus n minus 1 times our d, which is a 6. So it would be nice if we were done there, but we can do a little bit of cleanup work with this. So we're just going to do some simplifying to get a final rule. You'll always be able to distribute your difference in. So 5 plus, that's going to be a 6n minus 6. And as soon as you do that, you get two like terms right there. So we'll just put those together, but we tend to put this n term first. So 6n, and then 5 minus 6 is a negative 1. So here is the explicit rule for our arithmetic sequence. Now if I wanted to figure out what is the 50th term or whatever term I'm looking for, in this case, 1, 2, 3, 4, 5, let's try to find the 5th term, because I know that it should be a 29, but we'll see how we get the 29 from our rule. So if we want the 5th term, that's when your n becomes a 5, and all you do is you plug in a 5 for the n. And so we have 6 times 5, which is 30 minus 1, and you can see we're getting that 29. So you can find any term of the whole sequence just by plugging in, if you want the 10th term, plug in a 10 for n. The 100th term, plug in a 100 for n. So that is the explicit rule. The recursive is much less work, but it's a little bit limiting in, at least for this example, in what we can do with it. Recursive rule is where you have to identify the first term, and then the rule, you take the previous term, the a sub n minus 1 plus your difference. So we want to figure out what is our first term. A1 is 5, so we'll tell everyone what the first term is. And then the rule is you keep this a sub n minus 1, and now we need just to fill in the d. So our difference is 6, so we'll say plus 6. And there's the recursive rule. No simplifying or anything to do on that one. Let me see if I can move this. Oh, good. To generate the sequence from that rule, what you would do, if someone were to just walk in the room and say, hey, there's a recursive rule, let me write out the sequence, because people do that all the time, they would look at it and say, okay, I know the first term is a 5, so they'll write down a 5. And then they'll look at the rule and they'll say, all right, the rule tells me to take the previous term, well, the previous term is a 5, we just wrote it down, and add a 6 to it. So off on the side, if we had to do some math, we'd say, oh, the previous term is a 5, and we're adding 6. So our next term will be 11. Then you go back to the rule, and you say, okay, now I take my previous term. Well, the previous term has changed. It's now an 11. and we add 6 to it. And so our next term will be 17. And so as long as you know the previous term, you can always get the next term by adding 6. If I wanted the 50th term, I would need to know the 49th term in order to get it. And so recursive rules, a little bit limiting in what we can do with them, but pretty easy and quick to write. In the last example, you were able to find A1 and D, the two things you need to write an arithmetic sequence right away. That's not always the case. Another scenario you're going to come across is where you're given the common difference, but you don't know the first term. You're giving a different term, the 8th term. There's going to be a video for this, but I can show you what the setup will look like, and then you can watch the video for the details. You still want to follow your formula for an arithmetic sequence. And what you do is you figure out what you know. Well, you know what the difference is. So we know that this is going to become a 4 right here. We know that we don't know the first term, so I'm going to go ahead and leave that as A1. And then the question is, what can we fill in for this A sub n and this n? And that's where this 8th term is going to come in handy. Another way of writing the 8th term would be to say A sub 8 equals 36. And this subscript right here, that's what you're always going to plug in for n. So I know that in place of this n, we're going to put an 8, and then our minus 1 stays. And when you plug an 8 in for n into any formula, it's going to give you back the 8th term. Well, we already know that the 8th term is a 36, so that 36 is going to go over here. And what that leaves you with is an equation with just one unknown, just A1, so you can do some simplifying, find the first term, and then write the rule with the first term and the difference. Again, I don't want to take the time for it now because you'll see a video, but just wanted to give you a heads up. This is another scenario you see. Here's another example where you have to write a rule for an arithmetic sequence. Again, when we know it's arithmetic, we know what the rule will look like. That an equals a1 plus, I'm going to run out of room, n minus 1 times d. Okay, well that looks really sloppy. And so you look at what you're given. In this case, we know A11, so that's the 11th term, is a 43, and the 5th term is 19. To write an arithmetic rule, you need to know what the first term is and what the common difference is. Right now, we don't have either one. So this is the example that tends to be the most work because you don't have the two things you need. Just a quick show you, and I think I talk about this in the video also. If these are the terms, here's the 5th term, and this 5th term is 19. So I went ahead, I looked at that one first, and the 11th term, this 11th term is a 43. And what we are trying to figure out is what is that common difference between, that gets you from the 19 to the 43. So what we want to remember is that, you know, we are adding some common difference to get from term to term. So I know what, add the difference to get to the next term, blah, blah, and so on and so forth. So how we approach this is we say, well, what is that total difference between the two terms? And so we'll take whatever term is the furthest out. It could be smaller than the first one, so it's not, don't always take the biggest numbers, just whatever one, whatever term is the furthest out, so that 43. And we're going to subtract the 19, and that's going to give us that total difference between the two terms that we know. 43 minus 19, I think, is 24. And so we span a total of 24 numbers from this 19 to this 43. And so we want to cut that up into even numbers and figure out how many differences it took to get from one to the next. So we're actually going to divide this by, and here's where we look at these other numbers. The fact that you have the 11th term and the 5th term, whatever term again is the furthest out, 11 minus the 5, that's the number that you divide by, and that will tell you what that common difference is. 24 divided by 6 is 4, so we know that our difference is 4. And then from there you have a few options for how to get your first term. You know, if it's close enough, you could kind of work backwards. Sometimes that's a pain. Another thing you could do is, what another video shows you is, oh, what is it? You don't know the first term. Oh, that should be a plus sign. But now you know the difference is 4, so let's use maybe the fact that the fifth term is 19 to help out. So that 5 will plug in for n, so we could say, whoa, where'd that line come from? This is getting messy, I apologize for that. Where's my erase? There we go. Oh, I'm not going to be able to erase it. Anyway, you know that 5 minus the 1, and it'll be equal to what that term is, then the 19. And then you could solve for a sub 1 that way. Alright, so far we've had an introduction to an arithmetic sequence. A sequence is a list of numbers separated by commas. An arithmetic series is an expression formed by adding the terms of an arithmetic sequence. So for example, if I were to write one out, I could say 1, and you're going to see plus signs in between now. 3, 5, 7, 9. If you look at that pattern, you can see that we're increasing by 2 every time. That makes it arithmetic, and because we have the plus signs in between, it's called a series. Usually when you have a series, you're asked to find the sum of it, and so here we have 2 sum formulas for how to find the sum of an arithmetic series. And then let's just write down what the different variables stand for. So n is going to be the total number of terms in your series. So if I were looking at the series I wrote above, there are 5 numbers up there, so that would be a 5. A1 is the first term, so that makes sense. And then a sub n, that's always going to be the last term of the series. And then you divide by 2. Or another one that maybe is more convenient to use, it kind of depends on the information you're given, is this second one over here. Here you have n, there's that total number of terms again. A1 we know is, oh, hopefully you caught that, it just erased all that. I was trying to undo this line. A1 is the first term. And what else do we have? And there's that total again, and this time your difference pops up in this one. So 2 formulas that will give you the same sum, and you pick the appropriate one depending on what you're given. Alright, here's the last slide. I know this is kind of a lengthy introduction video. This notation we haven't seen before, although maybe you have, depending on our MCA prep that we did. This sigma, well, first of all, this is called a sigma. It kind of looks like an E. It's from the Greek alphabet. That represents, that's called summation notation. That means you're asked to find a sum. Here's the rule of the series, 14 minus 6k. If I were to write out the numbers of the series, you always start with this bottom number down here. So that's the start. And you start by plugging in a 1 for the k. So you would do 14 minus 6 times 1. Well, 14 minus 6 is 8. So I know that 8 is the first term of the series. Then you would plug in a 2. 14 minus 6 times 2. So 14 minus 12 is 2. And then you would plug in a 3. So 14 minus 18 is a negative 4. And that's, if I were to write out all of the terms, that's what you do. You start by plugging in this bottom number, and you plug in a 1, 2, 3, 4, 5, 6, 7, 8, 9. And how far do you go to plug it in? Well, that's what this top number shows you. That is the last number you will plug in. If we were to keep continuing with this, then our last term would be 14 minus 6 times 18, and I actually have no idea what that is. To find the sum, we would go ahead and add all those together. Well, nobody wants to do this by hand because there will be 18 terms, so that's where those formulas come in handy. So let me show you what that's going to look like. I'm going to erase all this, but that's, well, I'm going to try to erase it. That's what the summation notation means. All right. So for a problem like this, I think your summation formula that says your sum equals, whoa, oh, I remember, okay, I'm trying to remember what it is. It's n and then a1 plus an over 2. All right, so n represents your number of terms. Well, in this case, if you start by plugging in a 1 and you stop when you plug in an 18, there will be 18 terms. A1, well, we don't know what the first term is just by looking at the rule over here, this 14 minus 6k, so we actually will plug in a 1 to find it. Well, I guess we did that a second ago. So now we have our first term. Now an, because there are 18 terms, really is 18, but remember, think about that like the last term of the series. And to find that, you're going to plug in, I guess I need to know this now, an 18 for k, which gives us, what is it, 14 minus 108, so a negative 94. And those are all the numbers you need to plug into the sum formula. So now we go to our formula, sum equals, and our number of terms is 18, times a1 is 8, the first term, the last term of the series is a negative 94, and divide by 2. And then you just follow your order of operations. First add those together, then divide by 2, and then multiply by 18, and that will give you the sum. So it equals something wonderful, I'm sure. So that's a series. There's a video on that also. And there's your arithmetic sequences and series.